Hey, Algebra 1, here we go. 4, 6. Heading to the end here before Thanksgiving. Wrap this stuff up, take Chapter 4 test the day before Thanksgiving. Today we're talking about relations and functions. Okay, with our essential question, how can you determine whether a relation is a function? Well, let's define a relation first. What is a relation? It's a set of ordered pairs, x, y. Okay, and out of those ordered pairs, the domain is the set of x values of the ordered pairs, and the range is the set of y values of the ordered pair. What do I mean? Let's look at an example. Here's an example of a relation. Set, so we got the set brackets of ordered pairs. Those are each ordered pairs, points that can be graphed, that you can put on a graph. The domain is each of their x values, -2, 0, 4, 5. The range is the y values, 5, 2.5, 6.5. 2.5 repeated itself, so we don't need to rewrite it. So we got the x values here, just like we set up there, and we got the y values for the range. Okay, you're going to see that quite a while, so remember, domain is x values, range is y values. Alright, what is a mapping? It's another way to describe the domain and range, or another way to describe a relation. Okay, so you got the domain here, these are the x values, and these are the same numbers that we just used. Okay, the same relation. So this time I showed it. Here's the -2, the 0, the 4, and the 5 from the domain, the 0.5, 2.5, and 6.5. And you just draw a line showing the ordered pairs. Okay, 0 went with 2.5, 5 went with 2.5, 4 went to 6.5. Okay, so that's just another way of showing it. You got a relation in sets, set notation. The mapping shows it in a picture this way. What is a relation? When is a relation a function? So here's where we start to tie the two together. When each domain value maps to exactly one range value, okay, then you get a function. If you look up here, -2 only goes to one value, 0 only goes to one value, 4 only goes to one value, 5 only goes to one value. It's okay if they all come to the same y, but for each x you can only have one line coming off it, and that's all we have here. So yes, this is a function. This domain, you'll notice here at the 6, it goes to 4 and 5. That's not a function. The x cannot repeat in the relationship. Okay? X value cannot repeat. So if you're looking at that relation and you look at those x values and you find an x value that repeats, not a function. The y's can repeat, the x's can't. Okay? What is a vertical line test? This is another way to show if you have a function or not. Okay? You can look at the relation and see if any x values repeat. You can look at the mapping and see that the domain only goes off to 1 and not 2. Vertical line says if you had your points graphed, or if the line was graphed, you run a vertical line across your graph, and if it intersects more than once at any time, then it's not a function. If it only intersects once every time, then the graph is a function. Okay? So as we go across, if our vertical line, if our pencil hits that graph in 2 different places, not a function. Let me show you what I mean. Graph right here. Here's my relation. I look up here, -4, -3, 0, -4, 1. -4 repeated. So I know this is not a function. Okay? Also, if I looked at the graph, there's the -4 twice. And as I take my vertical line across, I hit 2 points at the same time. That's another reason why it's not a function. Okay? So vertical line test intersects at 2 points, not a function. If that point wasn't there, and I just go across and I only hit 1 point at a time, then I'd have a function. Okay? So relation, set of ordered pairs, you can show it in a mapping, you can graph it, you can tell if it's a function if the x does not repeat. Vertical line test will show you if it's a function or not. So that's relations and functions. One last thing I want to talk about here and that's a formal way to write an equation. Okay? You're going to start to see y represented by f of x. And that's how you say it, f of x, or g of x, whatever that happens to be. All we're doing now is showing a different way to identify each equation. So if we talk about 2 or 3 different equations at the same time, we don't have to say y equals y equals y equals and wonder which one we're talking about. We can call one f of x, we call another one g of x, we call another one h of x, whatever we want. This is just a notation thing. Okay? It doesn't mean f times x, it means f of x. Okay, so instead of writing y equals 2x plus 3, we'd write f of x equals 2x plus 3. F of x and y are the same thing. The other nice thing about f of x, you can identify different functions, but you can also now evaluate easier. When you put a 1 in here for the x, what that means is find y when x is 1. What's f of x when x is 1? So put a 1 in for the x and solve it. What's f of 3? Oh, x is 3. Put a 3 in for the x and solve it, and so on. So it makes that a lot easier to work with too. Okay? So we got relations, functions, function notation. We talked about relations in sets, in a mapping, and in a graph, and how you can identify whether or not it's a function or not. Okay? Tomorrow we'll look at that in class and do some problems on that, and we'll get after it some more there. All right. See you. Bye.